Hello everyone, I'm Xiaodong. Today, I'll be walking you through the PICO Emulator, what it can do, and how you can use it. With the PICO Emulator, you can build and test 3 types of spatial applications: native apps, web experiences, and games. You can create fully spatial experiences from the ground up, or start with an existing app and evolve it into a spatial one. No matter your development background, the emulator is designed to support you every step of the way. Inside the emulator, you can quickly prototype, validate, debug, and fine-tune your app. And because the emulator runs the full PICO OS 6 system stack, the apps you develop and test here transition seamlessly to real devices. To run the PICO emulator, you will need either a Windows PC with a dedicated GPU or a Mac powered by Apple Silicon. On Windows, we've optimized compatibility for mainstream NVIDIA and AMD graphic cards, with a strong focus on delivering improved working performance and stability. On Mac OS, we provide solid working support as well, powered by integrated multi-VK, so you can enjoy a consistent and reliable development experiences across platforms. If you've used other simulators before, the PICO emulator's interface will look and feel familiar. When it boots up, you will first see the desktop environment. By default, the background is set to pass-through mode, representing the real-world environment you would see while wearing the headset. There are several ways to install apps in emulator. You can deploy using adb commands, simply drag and drop your app file directly into the emulator window, or click Run to install and debug your app in one step. The emulator offers 2 interaction modes: controller mode and adjuster mode. By default, the system launches in adjuster mode. In adjuster mode, the cursor represents your gaze, simulating where your eyes are looking. A mouse click performs a tap gesture. This allows you to quickly validate the gaze and hand-based interactions using familiar desktop inputs. When you need to test controller-based interactions, you can switch to controller mode. In this mode, the cursor represents a controller's array. Each controller button can be mapped to a specific keyboard case through controller settings, enabling full controller functionality simulation directly within the emulator. In spatial computing, it's essential to explore your environment from every angle. The PICO emulator includes a set of powerful tools to help you do that. In the lower right corner of the emulator window, you will find controls for manipulating the simulated device. After selecting a mode, you can click and drag within the viewport using a mouse or trackpad to move around, tilt the camera, or rotate your view. To make things faster, we've also provided a set of shortcuts, such as right-click to quickly enter camera tilt mode, and WASD keyboard inputs for movement. In practice, you often tend to position the view at the right angle, then switch back to interaction mode to continue testing your experience seamlessly. The PICO emulator comes with a collection of built-in virtual environments, allowing you to see how your app behaves across different rooms and lighting conditions. You can easily switch between these environments using emulator scene menu in the toolbar, making it simple to validate your experience in a variety of realistic scenes. When building spatial experiences, there are times when objects don't appear exactly where you expect them to be, or when touch and action responses feel off. In those moments, being able to visualize coordinate axes, collision bonds, and other invisible spatial data becomes essential for debugging. In the PICO emulator, we provide a built-in Debug UI to give developers clear, visual insight into the Spatial applications. After launching your Spatial app, simply go to Settings, Debug, and enable the UI debug options. You can select one or multiple modes at the same time, combining them as needed to quickly diagnose visual and layout-related issues. Currently, the available debug overlays include audio components, coordinate axes, collision bounding boxes, molding bounding boxes, and container bounding boxes. Together, these tools help you pinpoint spatial issues with clarity and confidence. That's a quick overview of the PICO Emulator. To learn more, visit the PICO developers website. Thank you.